Welcome to the joy of coding.
Hello, and welcome to episode 103 of The Joy of Coding. My name's Mike Conley. We're going to be hacking on some Firefox stuff today, going to be digging into some performance benchmark stuff. The stuff we use to try and make Firefox fast, the tests that we use to make Firefox fast. It's in a similar vein to what went on last week where we were writing a performance test. I think this week, I'll give you an update on that shortly, but we'll be working on some other tests today probably. Who knows, maybe we'll go back to that first test as well that we were working on last week. But let me just switch my screen. Whoop. And show you the agenda. So here's today's agenda. Today is June 21st of the year 2017. I do this every time. I want to mention no plan survives breakfast. I kind of have a sense of what I want to do today, but I can't guarantee that that's how things are going to roll. This is not like a pre-planned, pre-scripted sort of thing. Whoops, didn't mean to click on that. I'm like that. Mistakes will happen. I will get distracted. Things will be stuck in quagmires. I'm trying to capture the real sort of software engineering experience when you're trying to fix a bug or a series of bugs, and sometimes that involves being stuck in a rat hole for a while trying to deal with things. And that's what I'm trying to capture here. So none of this has been I haven't got any pre-written solutions or anything. I'm doing this live and I'm making it up as I go. So no plan survives breakfast. Just a quick check, make sure you can hear me. Yes, I'm recording. Yes. I wanted to give one last, this is the last time I'm gonna do it. I'm gonna give one last plug for another show that I'm working on called The Joy of Profiling. And I've done 3 episodes. Here's 1, 2, and 3. Before I continue, I should point out that what you're looking at right now, the agenda, is actually available to you. If you are watching this on Air Mozilla, scroll down to the additional links section. There'll be a link to the agenda there. If you're watching this on YouTube, it should be in the I think I put it in the video description, although now that I think about it, it's possible that I have the links, I have the old links there. Let me just double check. I don't remember if this is the up-to-date link, and if it isn't, I will correct it. Hang on. Come on, I hope this is the up-to-date link. Yes, it is. Okay, we have the up-to-date link in YouTube, and then on Facebook. Oh, I never put in a comment. Let me do that right now. So I want to put in a comment with the agenda and rate this episode. Hold on a second. Let me do that right now. Normally, this would be done beforehand, but I was in a little bit of a rush and I forgot some steps, and I should really have a checklist. I'm usually pretty good at this, but sometimes I forget things. So let me just put the link to the agenda in a pinned comment. 1 second. Boom. There we go. So if you are watching this on Facebook, hopefully the comment will show up very, very shortly, and if it doesn't, perhaps reload the page because it's there now. I just put it up. And if you're watching this on Twitch, well, I'm going to drop it into the Twitch chat right now. So this is the link to the agenda, and if you feel like rating the episode, there are links to do that as well in all the places I mentioned, and on Twitch I just sent the link to do that. So bam, that's how you can get in touch, and that's how you can read this agenda and click all these links, and it will update as I work on it. As I type things in, it will synchronize. This little wheel will go like whoop 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 whenever it's synchronizing, and then if you reload the agenda, you should see the changes. So I guess I wanted to plug The Joy of Profiling. I've got 3 episodes. It's really just a series that I do with other engineers here in Toronto for now, looking at performance profiles from users and from people who work on Firefox and trying to figure out ways we can make Firefox faster. So if that interests you, check out episodes 1 through 3. And if you want to help participate, you can participate. Here are instructions on how you can gather a profile and a link to how you can submit a profile for analysis, and then we can analyze it live on the show. It's not exactly live; they're pre-recorded, but we analyze them on the show. So there's that. And there's an episode guide I should point out to the Joy of Coding now. Haven't been too many contributions, but that's okay. If you feel like sending a pull request, I'm happy to accept pull requests for whatever is useful for people who might be watching the Joy of Coding. It's modeled after something that the Handmade Hero uses. If you're not familiar with Handmade Hero, that's a live hacking series where someone is working on building a video game from scratch, and it's a very good series. So, what do I want to work on today? Well, I am trying to make it so that our animations team. Well, let me show you what. I'm going to show you something. Let me show you something real quick. Let me pump up the font here so you can see what I'm doing. And let me bring up the bottom because I know that the bottom is cut off for some reason. Okay, so hopefully you can see that. Let me just double check that you can see that. Yes, you can. Okay, so I'm going to show you. Let's see, rebase R4. These two patches are what I want to show you. There's this fellow Jim Porter who's working on a patch that changes how the loading throbbers work in Firefox in our tabs. And the patch is more or less done, but when we pushed it to our automation, we noticed that our Talos benchmark, and Talos is our testing infrastructure for performance problems and to find performance regressions. Talos reported a number of regressions, and so I've been digging into it for quite a while now, trying to figure out what is going on. And so if you're interested in my findings so far, I've got in the bug sort of a summary of where I've gotten to, because this was originally filed a couple of months ago, and then it picked up speed maybe a few weeks ago because Jim finished his patch, and we want to make sure he can land it whenever and sort of get out of his way. We want to make sure it's fast, and we want to get out of his way. So here is where we're at. So there were a number of regressions on these tests, and some of these are going to be super, super cryptic names like TP50 and then like some metric or something, and damp and quantum 1 session restore. I will explain the ones that matter. Suffice it to say that a number of these were reporting problems, and I've put a few of them out of the way. Like I've fixed or addressed or investigated some of them. So there was a TS Paint regression that was, I think, originally reported. Where was it? TS Paint here for Linux, and there was a TSVG regression that was reported afterwards, some session restore. So all of those have been taken care of, or at least I know what the problem is. There are a couple here that I still don't know what the problem is, and I want to figure it out. I want to know what the dealio is. And that might involve us using or building some tooling to figure out what the problems are. But before I continue, I want to show you what Jim's patch does, because it's actually pretty cool. Actually, I don't know, did I build it correctly? Yes, I did. So this is it. I don't know if you can see that. There's this like little loading throbber now that bounces back and forth in the tab. And for some reason, am I on the internet here? What's going on? How come I can't? Maybe the CBC's down. Let's try Mozilla.org. Okay, so there's that little bouncing ball, and then when the page finishes loading, we get this little burst effect that goes across the tab, and it fades out. And what's cool about it, like whether or not you like the aesthetics, but what I like about it are the performance characteristics. If you'll notice, that is animating at 60 frames per second. I'm not even sure if you could. It's possible for you to notice that because of the way that OBS is recording this, but this is animating as fast as possible. It is a super smooth animation, and that's because it's all using CSS transitions that occur off of the main thread and on the GPU. So we can fully accelerate these animations so that they're always smooth. Even if the parent process is bogged down or the content process is busy reflowing your crazy Facebook page, like we'll still animate smoothly, which is great. That's what we want. We want it to be smooth. But introducing this had the effect of regressing a number of performance benchmarks, and I want to investigate some of these now. Some of them might end up being the fact that the test is testing the wrong thing, or we're actually, there's noise. We've helped raise the noise floor inside the test. So noisy things that it shouldn't have been testing anyways, we added more to it, and that's being detected as a regression. Sometimes they're actually real regressions, like the TS Paint one was a real one, and that's because we were loading the SVG when we didn't need to. So um, so what I want to do first of all is well, I want to take a current look at where we're at um, in terms of the actual regressions. And if I thought about this, I would have done this before the episode. And I would have done some try pushes. We could do a comparison. But because I didn't, we're gonna have to go off of old information, slightly old information. This is from 2 weeks ago, so some of this might still be out of date. Um, but this is what we're gonna work with. We'll wait for Perf to pull up the numbers. Come on, Perf. Tell me. Oh, I went wrong. How would I reload? Anything? Yeah, okay, so that worked. I had to shift reload. So I'm only going to show the important changes, and I'm going to let's look at Windows for now. Number of regressions. We can ignore some of these because they've already been dealt with, like the session restore ones and the TP50 bytes one. Main RSS and private bytes I think we can put away. One thing I actually want to look at is the processor time one for TP50. Because I'm really interested in what's actually being measured there. But because I'm on an OS X machine, I'm think for now, for today, I think we're going to be restricted to these, which is the TP50 test. We don't have to worry about the TSVGR one anymore, thankfully. That's gone. So these two are taken care of. We can ignore those. But I do want to look at the TP5 one. We can ignore the session restore one. I want to look at the Kraken one. And these, I have no idea why those improved for some reason, but we'll not look a gift horse in the mouth. So TP50, what is that? That is a test that we have the snapshot of a bunch of pages from I think 4 or 5 years ago from the internet. We took a snapshot of like the Alexa top 500. Was it 500, 200, 100? We took a snapshot of a bunch of popular pages on the internet, and we saved them, and we served them up using a local server to simulate connecting to the internet, I guess, and browsing these pages. And then we time how long it takes to like load the page and paint the page. And the TP50 test, I think, does a subset of those pages. And you'll notice that on a number of these, we've regressed quite a bit. So these are the individual pages. You'll notice that on Amazon, Al Jazeera and Amazon, we regressed quite a bit. On Daily Mail, we regressed quite a bit. And the confidence was quite high, actually, that Al Jazeera, like, I think that's probably what I'll want to look at is find the one that regressed the most. In this case, it's the Al Jazeera one, and then see if I can reproduce it locally just running Al Jazeera. Because I don't want to have to load all of these pages. It's going to take forever. So what I like to do whenever I'm working with some kind of test problem or I'm working with a test is I try and reduce the cycle of like the feedback loop. Running the whole TP5 test suite, TP50 test suite will take a while, and that's too slow. I'd like to reduce it as much as possible, make it as fast as possible, even though it's still going to be pretty slow because it's Talos, and that's unfortunate. But I want to just load Al Jazeera. So let's try that. Okay, so we're in the bad state. And I'm going to need to, in order to reproduce this, I'm going to have to test both the good and the bad state to make sure that I can reproduce the problem locally. So let's collect a number for the bad state because we have the patches applied. And the way that this works is you run mock Talos test and then the name of the test. In this case, it's TP50. And then I'm also going to pass another argument called, I think it's no download. And the reason I'm going to do no download is because the list of pages comes down with all the assets, the actual pages themselves. And that list of pages is used to tell Talos which ones to run. And I want to override that list of pages so that I only run the Al Jazeera one. And if I re-download it every time, it will get overwritten. So let us, what was it, the TP5 manifest, TP5N, there's a manifest here. Yeah, it's actually the TP5O manifest. And I'm going to get rid of everything except Al Jazeera. So, erase just Al Jazeera, run TP5O, no download. Let's see what happens. Let's get a number. So Talos is going to boot up, and this is going to take a couple of seconds. This is going to take about 30 seconds because we have to, get all these packages, and then we initialize a profile like this. We make sure it's properly populated with things. It's actually quite annoying. We sit around here waiting for a while. While in the background the database is populated with various things, blah 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 blah. Come on. And eventually it will shut down. Possible I'll be able to bypass this if I okay, and then it finishes, and now we wait another couple of seconds because we're waiting for startup to sort of settle, and then we load the page. Lose Al Jazeera a couple times. Boom, boom, boom. We're gonna load it. I don't remember how many times this test runs. Maybe 20? 5? Okay, so we have our numbers. So this is in the bad case. In the this is the data that we want. And let me start taking some notes here. The notes that I'm looking at have been what I've been taking for all of the bugs. So let's just start a little section here. Let me boost up the font. Section here on TP50, and I'm gonna say with Squib is Jim's IRC nick. With Squib's patch, so the bad case, and then I'm going to do that. Now the other thing I want to do, actually, now that I think about it, is I'd like to get a profile from all of this. And I've been actually working on trying to make it easier to gather profiles locally whenever you're running Talos. And not just locally, but whenever you're running it in automation. Because those are super, super useful whenever you're trying to debug one of these things. And where is that patch? Make Talos TP Chrome. I think I've got a patch down here. Make page loader used. Yeah, this is what I want to rebase. Rebase that to this on top of central. And then I'm actually going to rerun the test, what we just did. I'm going to rerun it again, but this time I'm going to do it with profiling. And then I'm going to get a profile dump. Unfortunately, I'm going to have to do a couple of steps in order to make this work. So it's going to take a little bit of time. I'm not going to be doing a whole lot of coding for a couple of minutes because I'm mostly going to be doing some gymnastics here with rebasing with Mercurial, and I'm also going to build some things because I have to build symbols in order to profile properly, and that's going to take a minute or two or 3. And I wish I'd done this in advance, but I'm capturing the realness of development, the for realsies. That's life. That's life as a software engineer, I think. It is for me. I'm playing a sound here, but it's not working. Also the life of a software engineer. Sometimes the stuff you build doesn't work. Come on. Play the sound. Is this thing on? Hello? Reload. Come on, Wacky Morning DJ. There we go. That's what I wanted to hear. All right, so the rebase is done. Let us see. Um, Now there's this whip to deal with Kraken, TPS. Really, I just care about whenever we made page loader use the Talos parent profiler. That's the stuff that we care about. But I think I'm okay rebasing on top of tip. So let's do that. But actually, what this will do when I do this, I'll be outside of the state where we'll be running on central without Jim's patches. So maybe that's what we should test next. So I'm going to do mock build and mock build symbols. So we've got our symbols, because we need symbols in order to symbolicate the profiles that we gather. Blah, blah, blah. Kevin, aka Antares268 on Twitter, says the best thing about the joy of coding, from Mike Conley at the moment, is watching Photon make progress in nightly. That is nice. That is nice. So the Photon UI is making forward progress. I've got this nice little fancy menu. This little glitch on the animation, but like this is all smooth now. I'm quite pleased with how smooth these animations are. These are all accelerated in the GPU. Whoop, 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 whoop. That's all GPU accelerated. What else? Like that's nice. All of these, I think this panel, if we turn on paint flashing while we're waiting for this build to finish, I can actually demonstrate some things. I'm going to turn on paint flashing in the parent process. So there's this pref nglayout.debug.paint underscore flashing underscore chrome. What that does is it will allow me to see what areas of the browser are being repainted at any time because it shades it a certain color. And notice that in some cases we do like a lot of painting. So in this case, we're like doing this animation, I think, or this transition on borders or something, and that causes us to repaint on hover. But one thing to note is that throughout the animation of opening this panel, it doesn't repaint every time. The panel itself, I mean, it's kind of hard to see because it opens so fast, but like it doesn't like do this like flashy rainbow thing like we're seeing over the buttons when I hover. It doesn't do that for every frame of the opening animation, opening or closing animation. That's because it's all on the GPU. Same thing goes for like there's a little bit of repainting going on during these transitions. That was actually there was a bit of repainting there. What was going on? That I'm curious about. Why are we repainting? Is it because of my mouse? Hmm. Some of them we don't, but the web developer one we seem to do some repainting. And you know what it is? I think it's because um, we're growing the panel, so we have to repaint it as it grows. That's not a thing you can do on the GPU. So anytime we have to grow the panel, we do that flashy repaint thing, which is unfortunate. I don't think we can do that on the GPU. Yeah, anytime we grow or shrink it, that's happening on the main thread, which is not great. But the help one, for example, that one we only paint like beginning and end. When the transition begins, and then when the transition ends, we do this paint. It's like paint, whoop, paint. So during the animation itself, we don't do an animation. Anyway, that's just a little demonstration there of paint flashing. So I'm going to turn paint flashing off. How are we doing on our build? Still building symbols. It's going to take a little while. While we're waiting, let's see. Is there anything else to mention? Oh, you should come join me in the IRC channel for the joy of coding. So I'm in hash live hacking. There are instructions here in the agenda. If you go down to chat, I'm in IRC, and I'm on the irc.mozilla.org server in the live hacking channel. I invite you to come join me. You can talk to me there. You can ask questions. You can talk amongst yourselves. You can help me find bugs. I know at least there are a couple of you who watch who help me find bugs or point out where I make mistakes, and that's super useful because it saves me time, adds another pair of eyes, which is great. Okay, well, while we're waiting for the symbols to dump, let me see if let's look at those numbers that we gathered whenever we ran the Al Jazeera test with the patch. So one thing to point out right away, I'm going to pump up the font again, is that the first one, the first paint, takes the longest. And that's not super surprising because we're probably doing like image decoding and stuff, and then we cache it. So for subsequent loads, it's pretty consistent. We're like 205, we're in like the low 200s, the high 191s. These are milliseconds to get to paint, I believe. So there's kind of like this pretty even, like there's maybe a standard deviation. Actually, I shouldn't say that. I don't really know my stats very well, but like the value seems to be floating between 193 and 200 and something, 14, 15. So somewhere in there, that's where this value is floating around. So it's a difference of, say, 20 milliseconds, 20 to 25 milliseconds. Okay, so we're done dumping symbols. That's good. And what I'm going to do is, I think, did I unshelve? I didn't unshelve. So I'm going to unshelve, which means that our change to only run Al Jazeera will come off of the shelf. That's like git stash if you're not familiar with HG shelve. Smurf D wants to know, how did it go with last episode's test while the symbols built? Oh yeah, that's a good question. So Smurf D wants to know about the last episode's test. Well, it's noisy. It's still noisy. I suspect. So I did this hack. I think this was in the episode where what did I do? Where is it? I wrote this test, overflow test. This one. Yeah, I have this revision called screwing around, and what I do is like I overrode request animation frame, and I think elsewhere in that patch I was overriding set timeout because I suspect that there are things that are being driven in that test. Like there's like a database query. There's like all this stuff happening that I can't dirty frames for before, like, because that's the problem. I need to dirty the frames before any of that script runs, but there's no great way for me to always inject script before some other script happens. So it's a little bit of a whack-a-mole game. What might be nice is to find a more general solution, and I think I'll talk about that later if we get blocked on this one, because this whack-a-mole game is a little annoying, and I don't think it's going to work very well. But I'll talk about that shortly. It's 1:30 now, local Eastern time. Maybe in about half an hour. We'll see where we get with this TP50 stuff. Just hold on to your hat, Smurf D. Maybe I'll have an idea for how we can address this stuff later. So, mock talus test. I want to run the TP. I can just use the same. Yeah, the same command, but I'm also going to add gecko profile, and then I'm going to say symbols path, and I'm going to pass the absolute. I think I have to use absolute directory for some reason of my symbols that I just built, and they're in this zip file. Okay. Whoops! I need to not use gecko profiler, it's gecko profile. Gecko profile. So now we're going to have Talos spew out some results. And then maybe we can compare them. That'll be nice. Well, while I'm waiting for this to run, maybe I can talk a little bit about that idea I've got for that more general solution for the test. So the way that that test was working was that I was attempting to dirty the frames by um, running this like dirty frame script before any of the JavaScript runs. And that's really fragile because I have to like find all these places where script might run and then find a way of making sure my dirty frame script runs before. Oh, I guess we only do 2 cycles if we're running with profiling. Okay, that's probably all right. So let's check out this profile and see if we've got usable profiles from it. Because if so, then we'll apply Jim's patch and we'll compare. So from Al Jazeera, we have a 1.5 meg profile. That looks like it's going to be what we want. Yeah, that looks good. And we've got symbols. Okay, we're in good shape. So this is the first run here. This is the second run. And now I'm going to upload this so I don't have to keep track of it on my file system. I'm going to say TP50. That's where we were. It would say without Squib's patch. This is the good case. And that's the profile. And what was the score that we got? It was up here. Now notice that it's a little bit slower, the average, than with Squib's patch, but that's because we were profiling. Profiling adds overhead, so we can't really compare those numbers. So I'm going to get rid of that. I'm going to shelve the changes that we made. Then I'm going to rebase Squib's patch on top of this stuff, and then run that whole test again, and then we can compare before and after, and that's going to be, I think, useful, hopefully. So let's rebase Jim's patch. So what are he's got these 2 changes, this one and this one. So I'm going to rebase that to this. So this is like a little bit of surgery on top of tip. And then once that's rebased, I'll build. I don't have to rebuild symbols again, thankfully, because none of Jim's work changes any of the binary. So we're just repacking stuff in the OmniJar. So the symbols should still all line up with the memory addresses that the profile spits out. I should get some sounds going. Okay, here we go. So we've got Jim's patches on top. We're going to switch up to them. And then I'm going to unshelve the change, build, and then rerun the test. And while we're waiting for that, let me talk a little bit more about my idea for that solution. So yeah, injecting JavaScript before each one of those places where JavaScript could run. So like when a search results comes back from places, that's a whack-a-mole game, and I think that's going to not scale properly. That to me is a pain that will always be there. The more places that show up where we can have script run, the more that we have to like continue to monkey patch and do these awkward things, and I'm not super jazzed about that. So what I'm going to propose instead, and actually I think I filed a bug on this before, was a way that I can tell some window every time you attempt to check whether or not the frame tree is dirty, just say yes. Just say that the frame tree is always dirty. And that way, anytime we run script that attempts to like get layout or style information, it'll say, oh, dirty, and then it will cause a reflow to occur, because that's what we want to do. We want to simulate the worst case scenario, which is, um, you know, the frame tree is dirty whenever script runs. Okay, so that's done. And let's see, we're gonna run the test now with Jim's patch, crash report symbol. Okay, yeah. So that bug is maybe one we could look at today once if we get stuck here, and that's going to be pretty tricky. I don't know the layout code that deals with dirty frames and stuff that well, so I'll kind of be figuring it out as I go. But that's how this works. That's how this works. I never know what's going on, and you can quote me on that.
I can't do my work. What happened? Hey, what happened?
All right.
Hi-oh!
And finally, also there are some sounds I haven't played in a long time, like yeah, that's a good one. Okay, so we're running the test now. I'm just gonna back off from playing sounds. I try to influence the test as little as possible. Okay, so here's our score. Let's compare them. So this is really annoying because with Squib's patch, we actually perform better when I'm profiling. Ugh. So maybe what I need to do is run with more cycles. I don't know why it only ran with 2 cycles. What was the command that was sent? So somewhere in this spew, we'll see what was said. TP page cycles 2. And I think whenever we run TP50, there's the Talos test stuff. TP50, I think by default we're supposed to be doing 25. So why were the TP? Why are there only 2 cycles here? Let's find out. Page cycles. Let's see where we influence them. TP cycles. No. No. It's supposed to be 10. Why would it become 2? Why of all places would it become 2? And it becomes 2. It seems to become 2 in the command line that we pass. So utils, here's the command line. If we're profiling, extend TP profiling info. I wonder if page loader itself, no, because where would it be? Generate browser command line. Where's that used? That's the definition. This is where it's called. Path args, profiling info. Cycles. Test config, dictionary run test. So who passes the test config? And Talos. Test. File, web server, results. Cycles. Oh, if profiling is on, override TP page cycles to prevent test hanging. What? Reducing the number of cycles. Please disregard reported numbers for cycle and TP cycles. Cycle var. So he's only doing 2. I'm going to change that for now. And on line 57, instead of doing 2, I'm going to do 10. So we're going to run that again. We're going to get 10 cycles. So that was a little annoying. Had to figure out. Talus is a little bit of a nightmare. It's an older piece of code. Much love to the people who work on it. They inherited a mess and they've been slowly improving it. So it's not a knock on the people who work on Talus at all. It's just it's an older piece of code that has only recently started to like make more sense as people work on it more. So much love to the people doing that. Shout out to Joel Marr and Rob Wood. I know they work on that. I don't know if they watch this show, but I know that they work on it. Okay. 3, 4, 5, 6, 7, 8, 9, 10. Boom!
That's right!
Okay, so here is the profile that we have now, the set of profiles, or is it one profile? Let's see. If I load it up, I think it's actually going to be one profile, yeah, a cycle. And then load. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then the test finishes. So this is with the patch. And hopefully, I'm going to, hopefully whenever we take off Squib's patch, with Squib's patch, things will perform better, and then we can compare. Now, if they don't, then we have to potentially increase the number of, like, it's possible that the regression is due to the has more to do with the maybe the going between pages, because it'll load one page, then another page, then another page, and maybe I'm getting rid of the regression by loading the same page again and again. So we shouldn't give up if it turns out that loading the one page has nothing to do with the regression, or like eliminates the regression. We just need to change our assumptions a little bit. I am super caffeinated. Holy smokes, my heart is racing. If I have a heart attack here on this stream live, please send help. I'm in the York Mills meeting room in the Mozilla Toronto office. Woo! All right. So let's build that again. Oh, hang on. Let's unshelve. Wait, did I unshelve already? Yes, I did. Okay. This shouldn't take too long. Almost done.
Mamma mia!
I'm going crazy with the sounds today. It's crazy with the Cheese Whiz. Come on, and we're done. Okay, so now let's run the test again. This is without Jim's patch. So hopefully we'll see an actual improvement in the numbers, and then we can actually compare the two profiles. And if that doesn't work, well, then it's time to stop the profiling and just see what the minimum thing we need to do is to reproduce. Because like these Talos tests, I think that it runs like in a deterministic order. It will always load this page, then this page, then this page in that big list I showed you. And I wonder if that it's the transitioning that for some reason is having the regression be reported. So here we go. Brace yourself, selves. Maybe there's more than one person watching this. We'll see. Okay, we have some numbers, and the average was 234.50, and the average over here was 229. So it is still better with Squib's patch. That's a pain. That means we haven't reproduced the issue yet. It's 465 and then 202. You know, we might be able to do something here because, like, notice how the second one was more expensive for some reason. A little bit. Nah, you know what I need to do? We're going to go back and we're going to do the... Where is it? We're going to change the manifest. So I'm going to run the first 4 pages. Let's do these. Actually, the first 3. I assume that they're going to run in order. So if Al Jazeera was reporting a problem, then it's these 3 that I think I just need to run. So let's run those 3. So let's do this again. Running those 3. And so I'm going to get rid of the results. So again, our results are invalid. Invalid. And invalid. And invalid. And invalid. Come on. Invalid. Okay. So that's our test without Squib's patch. We have these like 3 scores. And Al Jazeera was like 224. And the total score, like if we look at the total score, do we have anything here? Not really, and that's okay. But we should also capture this profile and make sure that, because we did some profile capture there. We should write that out and upload it somewhere. So still, we want the Al Jazeera stuff. What? Where is it? What? Where is it? I'm getting confused. Here, close all these windows. This is confusing. There's too many of them, and because I've been doing this kind of profiling again and again and again. So I got too many windows. Close, 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 close. Close, close, close. All right, so let's open up that zip file. Al Jazeera. There it is. Okay. Good stuff. Upload. And that was without Squib's patch. Okay, and have I shelved? I have, so now let's go to the tip, unshelve, build. Back and forth, back and forth. And then I can actually type in a command and press enter and it will do it immediately. And then mock build. Come on. There, now we're building. Now we're building. Ah. I think I don't necessarily have to do a full build. I think I'm supposed to be able to do mock build faster, but I've found that sometimes that doesn't work. And I wonder if that's because no, I have no idea why why that is. I just get a little paranoid sometimes, or at least I've gotten paranoid with this patch. And I had unshelved, so now I can just run this test again. We're going to do it again. Same biz, and hopefully in this situation we're going to find that we have a regression in the Al Jazeera benchmark. So we see Squib's effect up there. That's great. Come on. It's happening. Come on. There it goes. Loading stuff up. Yep, this page was in the Alexa, like, top something or other way back in the day. 2014, I think. Okay, so here's the score. Let's take a look. Let's compare. So with Squib's patch, Al Jazeera has an average of 273. Hey, we have a regression. Boom. There's one. There's the other. So um, yeah. Wow. This like the first frame went up a lot. Second frame goes up a lot. Everything's just up. This is great news. We and actually, do we have a regression here as well? 330 versus yeah 282. That's useful. And then 326 versus 328. So no regression on the first one, but like something about these two seems to have caused a problem. Anyways, we have our regression, so that means we can open up our profile, take a look. It's in a book, Reading Rainbow. All right, so let's upload this. So this is the bad case, is what we're looking at right now. I'm going to share this. I'm going to upload it. So you can look at it too if you have this agenda in front of you. You can click on these links here. I hit save. That's up synchronizing. Whoop, 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 whoop. So reload the page if you're looking at the notes. You can look at the profiles with me. So we know that the very first frame cost 478, or the very first load is 478, and it was 366 without Squib's patch. So that's actually that's like 100 milliseconds of a difference. So I feel like if there's any kind of signal, that's a great place to look, is the very first frame, and that's this one, the very first time we paint it. So let's look at this. This is the bad one. So in order to, I'm gonna, unfortunately there's no great way for me to label this profile, but I'm going to say that the right tab, that's what we're looking at right now, this one, on the right side is the bad case. So it's like before and after. Bad is on the right, and good is on the left. So we're looking at the good one now, and I'm going to zoom in. So we're looking at good versus bad. Good, bad. Good, bad. Now, bads, like this little, I don't know how easy it is to read this. 496 milliseconds is spent, more or less. Actually, I can make this more precise if I zoom in more. 478 milliseconds over here, and then over here, yeah, it's a lot less. 374, which is quite a bit less. So 367 versus 478. It's about 100 milliseconds difference. That's great. So we have the regression in front of us. Hello, Joe Fish. Joe Fish caught me streaming. So we have the regression in front of us. This is good. So let's see if we can find it. We can get rid of some noise here. We can get content process 1 is not doing anything. This sort of like even line going across is us. If you look here, we're in mock message trap, and that is the way in OS X of saying, I'm not doing anything. I'm waiting for some messages. So that is an idle content process, so I'm going to get rid of that one. Content process 2 is the one that's actually loading Al Jazeera. I think it's the same case in the good case, so I'm going to get rid of content process 1. And so now we have our 3 threads: main thread in the parent process, main thread in the content process, and the compositor. Compositor's not doing much either in the good case. And in the bad case, it's doing a little bit more, but not much. In the good case, we have this like delay and then another delay in the content process. And then we have like 3 delays in this case in the with Squib's patch. Now, why is that? Why would that be? And there's like this gap in the middle. So let's take a look at the, and that's really interesting because the content process is not supposed to be affected by Squib's patch. That should have nothing to do, like showing this little throbber is not supposed to have any impact, but it must be. I mean, we can consistently reproduce this problem. These little markers also tell me things about what's going on, like there's a paint there. There's a paint here, 37 milliseconds in the good case, 29 milliseconds in the bad case. That's not it. But these like big delays, like this one cost 122, this one cost 163. Here's 55.96, and then on 177. Like, what is this? What are we waiting for in the content process? I suspect this is us doing like layout. And is that what's going on over here? Yeah, 2 layout. So this 177 and this 163 are kind of comparable. They're doing more or less the same work. So for now, let's ignore that. What's interesting is a couple of other things. First of all, there's all this stuff going on around, like afterwards, after we've painted, here and here. And the difference in the stuff afterwards is, let's see, we've got 89 milliseconds in the bad case, and in the good case, we've got something like 36 milliseconds. So that's about 50 milliseconds difference. So that's maybe half of our regression is right there afterwards in the stuff that we're measuring after. And then we have this little window of time here. What is this? And then we have this like delay here. What are these things? So this delay, this sort of like little gap here is another 48 milliseconds, which is gone in this case. In the good case, we don't have that little delay. What is this? This is us doing networking, processing a networking response and getting a cached value back. So that's all networking. What else is going on in here? Like let's look at just JavaScript. Is there anything that's just JavaScript related? I'm really just kind of like guessing right now. The shapes look similar. Nothing too different. There's like a little bit of extra JavaScript going on here in the bad case. Although maybe that's just this and this are the same thing. So So maybe let's not worry about that. Let's combine the stacks. Let's look at this window of time, actually. In the bad case, let's look at this window of time. I think these two are somewhat comparable, but for this one, we're like, other stuff's going on. Let's invert the call stack, doing a lot of waiting there. Here, why are we waiting? We're waiting for a synchronous message because in the good case, we're like sending a keyword to the parent. So we wait a while for that keyword to come back. That happens here as well. We're waiting for a keyword. Yeah, sorry, I was looking at the wrong process before. So keyword 56 milliseconds over here. It's about 42 milliseconds in the bad case, so that's not it. Here we're doing some jitting. It like, what do we, pickle? Pickle. Some kind of pickling going on. We're doing like, there's this networking stuff that, is that happening in the, I don't see it happening in the good case. It's like a message received. But there's this like networking stuff going on in here. What is this? Networking set request header, like invert. What is happening? Processing, we're preloading a URI. We're doing script loading and preloading a URI. Something tells me I am barking up the wrong tree. But let's just check. Preload. Yeah, here's the preloading. That's not unusual. That's happening. And preloading, all the stuff with preloading takes about 14 milliseconds. And that's pretty comparable. There's a little bit more going on over here that I'm not seeing in the good case. So maybe what we really need to be focusing in on is what is going on over here in the bad case. We're parsing some JavaScript. We're compiling JavaScript. We spend 32 milliseconds running the HTML5 reflusher. Reflusher. I don't see that there. Oh, it's here. HTML5 reflusher. 32 milliseconds. Yeah, about 32 milliseconds. So it's moved. The order has changed, but it's over here in the good case. Let's zoom out. So reflusher, but it's running twice, here and here. Whoops, whoops, whoops. Let's zoom back in. It's running once in the good case. It's running twice? "74 milliseconds versus 32. That's interesting. It looks like it's running twice. Once here, and then once here. Why would that be? Reflusher. Because of a schedule, we're processing pending events. And what's in here? What? The hang monitor kicks in. Okay. Dispatching message. vsync. Receive a vsync. Why is the reflush happening twice is what I want to know. Flusher. One's here and one's here. Maybe process script. I wonder if it's because the page is loading multiple script elements, and then over here the script finishes loading. What is this? Cookie service? Where does the, if we look at the timeline in the content process, finish and unload there, and then the load event is right here. That's where we finally loaded. Process styles again. DOM content is loaded here though, and in the good case, let's look at the timeline. Here, I'll zoom in a bit tighter. DOM content loaded happens about there. So they load, the DOM content is loaded around the same time, but like way more stuff is happening. Like look, there's this like refresh driver tick happens here that's taking forever. That, oh no, that's the same thing. 63 milliseconds, 78 milliseconds in the bad case. I guess that's not so bad. A reflow occurs there. That is, yeah, about comparable. 41, 34. Okay, takes a little bit longer. Refresh driver tick again. And then like all this stuff over here. More refresh driver ticks. All of, like, I wonder if this is the majority of it, is just like, why are we sticking around? Like the page is done. What are we waiting for? DOM content is loaded. The load event fires here. What are we waiting for? Why didn't the test stop? Is it because the parent process was busy doing stuff? How do these TP5 tests work? They're page loader tests, and the way it works is, let's see, page loader, content, paint handler, we get a Moz after paint event, and then we send a message called load event, page loader load event. Now where is load event comes up here. If the test does not do its own timing, otherwise we do load handler. Load handler. Load handler says load event handled, and then we record the time. So if the parent process was busy doing stuff, the content process probably sent the load event handler. Like where's load? What are we waiting for? Moz after paint? I don't remember again. How do we get here? Load handler. Wait, PL painted. It happens. Frame script. Load frame script. So when we see a Moz after paint event, right? Content paint handler. We paint again, paint again. And what's the parent doing up here? Let's look at the parent process for a little while. What's the parent doing? Dealing with some caching stuff. HTTP request. So I wonder if this is a case of, like, because we've painted, we have presented, That's done. We painted right here. We like here's the rasterize. So here's layout, rasterize, layer transaction, composite. So assuming that this is us painting Al Jazeera, which I think it is, if we look at the paint, yeah, Al Jazeera, this is the layer upload. Let's take a look at this. This is the layer upload, and this is whenever we should be presenting. Composite. Boom. For transaction, layer upload, composite is super cheap, and that's when the test should have ended. And that is how long? 380 milliseconds, which is roughly comparable. Okay, I'm starting to think that this test is flawed because it's waited too long. It like waited for, here's another DOM content loaded? What is going on? Why? Two DOM content loads. DOM content loaded, then DOM content loaded again. Are these like subframes? DOM content loaded. What is loading? DOM content loaded. It loads jQuery. jQuery says it's ready. And then over here, DOM content loaded again. What's happening? Some image is done being loaded. A marquee. We're running the marquee thing. And then we paint that in composite. And like marquee, what? Marquee. This is marquee in the, oh, there it is. Load. jQuery. There's jQuery. There's jQuery over here. Load jQuery. And what was this? This was, oh, jQuery was running to create something. It's attempting to get a property on the DOM content loaded event. A mystery. I still think that this section over here is very troubling, or like this is maybe where a good chunk here and here, these two gaps do not exist as badly. Like there's no gap here, and there's only like how long is this? 36 milliseconds over there versus 90 milliseconds over here, and like what's going on? So let's zoom in on this again. Actually, bad case and good case. It's like good cop, bad cop. Let's take a look at the events in the timeline that's going on here. In the good case, more refresh driver ticks are coming in. That's not unusual because the and we're painting. We do a paint here and a paint here in the bad case, or in the good case. The load event happens there. We do like another paint over here, and we do a paint in the parent, I think. What are we painting? No idea. But we do an extra paint here and here, layer upload, and then composite, and then we're done. Load event. End page load. Load event here. Load event, load event, load event. Page load. To was my scope function the marquee? Okay. Why did this happen so much after? Like, that happened 60 milliseconds after the beginning, and over here it happens 24 milliseconds. So what's the delay in getting to the load event? Well, we do an extra paint. That's one thing. We do a paint here. Why? Then we wait a while. It's like we're waiting for something. We're just waiting there. We wait for 36 milliseconds. We're just waiting around. Do we do any waiting? What is it? Mock message trap. We wait for 36 milliseconds there. And we don't do any waiting in the content. So that's, I think, where it's coming from. It's just this waiting that happens in the content process. We're just waiting around. And the parent, what are we waiting for? What are we waiting for over here? We wait for this message to paint. This paint message comes down, or like the instruction to paint. But getting to the load event takes forever, and we're just waiting. Why? Why does it take so long to get to the load event? We paint here, Al Jazeera the portal. We paint here again, Al Jazeera portal. Here's a end page load. Why aren't we firing the load event here? Hey, here's the load event. This is it. This is why, what? Here's a load event right here. Why is that not what we're dealing with, what we're responding to? Load event. Hey-oh, DOM content loaded and load event. That seems super important. And like, what? Where is it? Detect login manager. I'm becoming more and more convinced. So this load event is, I think, what we actually want. Where are our load events in here? Load here, here, and here. Here. That's in the good case. In the bad case, we have loads here, here, and then here, and this big gap between those two load events. And most of that gap is waiting, I think. Fire scroll event, content loaded, styles, rasterize, rasterize, rasterize in the bad case. We rasterize once. We only rasterize once before firing this load event, you know. We rasterize. We do like the whole kit and caboodle. An extra 16 milliseconds-ish of work here. 9 milliseconds, that's not so great. But then we do all this waiting. Why? Why do we wait? Why are we waiting? Why are we waiting? Oh, why are we waiting? Oh, why do we wait? Why are we waiting? We should be animating. Oh, why do we wait? Why do we wait? It's my little song. One, we had 2 refresh driver ticks here. And then we're done. Whereas over here, like take way longer. Let's try and understand this load event more. So like when we run Talos, when we run these tests, the test is what we call a page loader test that does auto timing. Whenever if a test is supposed to wanting to like manage its own timing, then it puts like a little percent sign in front of here. Does own timing. Yeah, here when we parse the manifest here, we look to see if there is an percent sign. And if so, then we say that it does its own timing. Otherwise, it doesn't do its own timing. And if it doesn't do its own timing, then we enter this branch. We're adding a message listener load page. We add a message listener for the load event and the record time. Then we open the page, start and load, and then we're going to say load event and record time. We add this message listener to this thing called content listener. What is content listener? Okay, that's this thing. What is the difference between load event and record time? Well, page load or record time is, I think, called manually within the test if the test is recording its own timing. Otherwise, we listen to page load or load event. So that's this thing. We use Moz after paint. In E10S, we say get interface dominant utils. If there is a Moz after paint pending, what does that mean? Then we add an event lister to Moz after paint. Content set timeout content paint handler of 0 when we set up the browser. Is it Moz after paint pending? I wonder if this is it. assume we're using moz after paint, and use moz after paint. That comes from, yeah, moz after paint, and I'm pretty sure that's what we're running this with. When you run the test, you say test go TP moz after paint. So we're using moz after paint, and so I'm trying to parse this grossness. Okay, content load handler. So we run. This is what we're doing. We run content load handler. We define this function, and this is so gross. And inside that function, we check to see if, oh, we add the event listener for load here. We also, inside content load handler, I think we're still inside that function here. So that is a sending message. So that's inside here. So inside the content load handler, we also define a content paint handler. And so after the load handler has fired, we say, well, when you get a chance, attach this content paint handler. And this content paint handler goes, well, let's get the DOM window utils, see if there's a moz after paint pending. And what does that mean again? It's been queued but not yet fired. Okay. Otherwise, we say load event. We've loaded. But if there is a moz after paint pending, I wonder if that's what we're entering. And then we wait for a paint. And then we fire this thing. That's my theory. Is that we see this load event here. Any of these load events. Load event. Load event. Here. Let's say we see this load event. Let's zoom out a little actually. We see this first load event right here in the test. Then we queue this timeout, and who knows when that'll fire. Sometime whenever the content process is free, I guess, so somewhere in here. And then we say, hey, if there's a moz after paint pending, which there probably is, and we're going to wait for the next paint. So suppose now that that timeout fired after this paint. So say it fired in here. Or even better, say it fired over here. No, let's say it fired here after this paint. And then the moz after paint event fires here, and then by the time the parent reaches it here, we've added all this time. That's what I'm starting to suspect is what's going on here. Okay. Okay. I think we have to try cleaning up this test a little bit. Now, that was looking at the first one. Let's see if we can uh, notice the same sort of problem happening on the second run. 260 or 206 versus 261. So let's zoom out. Let's get rid of mock message trap. Look at the call tree. Let's look at the second run and zoom in. So here there's this big gap in the middle again. And there's less of a gap over here. So maybe there are multiple parts to the problem. But that gap seems to be the consistent thing. Like, let's look at the third one. Yeah, like look at them just zoomed out. Gap here, gap here, gap here. No gap here. So on the 1, 2, 3, on the fourth one, 1, 2, 3, 4, we had 243, and then 1, 2, 3, 4 is 202. 2, 3, 4. That's interesting. There was no gap there, but there was still like still a regression. No gap here on the fifth one either. 1, 2, 3, 4, 5, 248. Still quite high. Well, then maybe let's take a look at one of those. Let's take a look at 1, 2, 3, 4, 5, the sixth run. In the bad case, and the sixth run in the good case. 1, 2, 3, 4, 5, 6. Zoom in further. So bad case, 258 milliseconds. Good case, 215. So we have captured some kind of regression here. It's about, I'd say, 43. Yeah, 43 if I've done my math right. Yeah, and that's about right. The difference between those two is about 43 milliseconds. So we've captured the regression. And what is the difference? Well, there's all this blocking happening on the tab thread. And what's going on? Like, why? Why are we blocking? Well, we're running a URL security check there. We have these keyword to URI, these handler things. Those were running over before. Why? This is presumably still blocking the main thread. I don't know why this is not complaining about that, and why we don't see the red bar on top. Oh, I've got the call stack converted. Sorry. Good and bad. Good and bad. Let's, whoops, I keep moving the window. Okay. There's that reflusher again. Okay, schedule group. So there's some scheduling going on here. Schedule. Scheduling of stuff, 160 milliseconds in the bad case. The actual like style calculation and refresh driver takes was 27 and then 24, 24 and then 21. That's about the same. The actual like style and reflow and painting is about the same. It's all the stuff around it that seems to be taking more time. Like running the HTML5 stuff. We have an async event dispatcher happening here that is 44 over there. It's 56 over there. Okay, not great. 40 over here. 52 over here. That's just more expensive. And then another HTML5 executor flush. And then this like message that we did composite. We start request. Did composite. Okay. That's supposed to be pretty cheap. destroy event. Ooh, and then yeah, we're running that. Yep. 68 milliseconds versus 72 milliseconds. Okay. Why so expensive? Let's invert the call stack, see if we can shake some sense out of this in that way. We're waiting for 44 versus 34. That's not great. And then a mock message trap for 12 versus 8. It's a little bit more. Profiler thread. If anyone's seeing anything that is jumping out at them as like, whoa, that's weird, do let me know. It feels like things are just generally more expensive, but I don't know why. Parents nice and happy. Parents not doing anything. It's just waiting around here, waiting around there. Doing a little bit more over here. Changed. State change. I don't think the parent is like that's where all the changes are, but like why? Why is it taking so much longer? These synchronous messages keyword to URI. Let's look at the timeline. Big style calculation, reflow. Yep, that's about right. And these are cookie things. 1, 2, 3, 4. Cookie, cookie, cookie. DOM content loaded over here. Yeah. And what are these? Message keyword URI. Yeah, all these. This one's 9 seconds. This one's 7.8. And then a refresh driver. Take a reflow. Handler service. Message exists. Handler service. Yeah. That's the unload of the previous page. Everything's just taking longer. Why? Why? In the good case, we paint here. We rasterize, we forward. Over here. Forward transaction. We're not rasterizing. We're rasterize. Here, here, and here. Are we gated on the GPU for some reason? No, GPU's happy, barely doing anything. Getting these profiles was really supposed to clear things up, but it's really not done that job. Is it that we're waiting around again more than we thought we should be? Mock message trap. In the content process, we're waiting around for 12 milliseconds in the bad case, and about 8 milliseconds in the good case. That's not so bad. It's again just like a little bit longer. Why? Why? All right. I don't know how much longer I want to dive into this, but let's do like little chunks here. Message handler exists. runs here, actually runs a couple of times on send exists and send keyword URI. Psync wait. Send keyword. Send exists, send keyword URI. And the cookie string happens again. That's fine. Spin lock for date time stuff. 24 milliseconds sending the keywords. 16. Maybe we can look into why that is. What are we waiting for? Sending the keywords. Why? We run all this stuff. We send, I'm guessing, a synchronous message. And the content link handler and a link event when a link is added. (16 milliseconds versus 24). And where is that being spent? Well, we spend 14 milliseconds there sending that. We spend 12 milliseconds there doing that. On link event, 6 milliseconds over here and 2 milliseconds. Okay, let's dig into that. Why? Sending a keyword is 6 milliseconds here. Over here, sending the keyword's 2 milliseconds. So send keyword to URI. What is that? Keyword to URI. Is that a that's a message that we send over. That's a synchronous message that we send to the parent process. And I wonder if the parent's just bogged down in the bad case. The parent doesn't have a chance to respond as quickly. Like in the parent process, we're spending how much time waiting and servicing events? Mock message trap. 138 milliseconds. And in the bad case, mock message trap, we have more time, or, oh, we're waiting a lot less. Oh wait, I got the wrong process selected. 158. But that's like let's look at the slice just while we're like after all of these keyword URI stuff. Like how much are we waiting? 18 milliseconds in the bad case, 14 milliseconds in the good case. I thought that would clear things up. It really doesn't. Styles, composite, composite, composite in the bad case. Only one composite here, and another composite. It's a long composite of 5.46. These are really short composites. It's interesting. Reflow, short composite. All right, 97 milliseconds in the back case, 74. So we have a deficit. Twenty 23 milliseconds. Where did it go? Where did those 23 milliseconds go? here for the exists message. We wait here, same thing. Is this amount of time the same up to the reflow? Or, yeah, up to the reflow. 32 versus 42. So there's 10 milliseconds lost here. Why? There's a wait right there. It's the same wait. Destroying the tab child from the previous page. Refresh driver. Flush. VSync. VSync. Good, bad. Good, bad. Good, bad. P-handler service. And then this get keyword for URI is quite a bit longer. This get keyword for URI takes 6 milliseconds. And this one takes 1 millisecond. That's interesting. Let's just look at this little chunk. Keyword to URI. Yeah, that takes a little bit longer. And so the parent is failing to respond in time because what are we doing? We're painting. The paint happens just like we request it, and we burn a lot of time because we're painting. Whereas over here, we're already done painting. What were we painting in the parent process? Oh, sorry. Parent process. Animation finished. We're just painting the browser. Just as this message comes up, it's like bad luck on that one where we paint and this message slows down 8.17 milliseconds. This one's 8.98, but this one slows down because we're busy painting. This one, the paint happened earlier. It's like a scheduling problem, but there were one paint. There's a paint here, and then there's a paint here. We do 2 paints in a row. We do 3 paints in the parent process. 1, 2, 3, 4. We do 4 paints the main thread we rasterize 1, 2, 3, 4, 5, 6, 7 times. Rasterize 1, 2, 3, 4, 5 times in the good case. We paint less. Good, bad, good, bad, good, bad. I wonder if these it's just bad scheduling. What time is it? 2:51. Good, bad, good, bad, good, bad, good, bad. Anything jump out at you? This is the one that jumps out for me, but also this one. That gap in the middle again. Good, bad, good, bad, good, bad. Bad has 1 paint, 2 paint, 3 paint in the parent process. Good has 1 paint, 2 paint. These are shorter paints, slightly. All these little frames. That delay takes 60 milliseconds. This delay takes 59. It's about comparable. Parent process. What you doing? Mostly waiting. 6 milliseconds. Whoa, in the good case, we're waiting a lot more. Hey, yeah, the parent is... Wow, a lot busier, I guess. Wait, good, bad, 272. We only spent... Am I reading this right? When I invert, 6 milliseconds. Am I inverted over here? I am inverted. I wait a lot more versus over here. Oh, yeah, 100. Why was that math wrong? 154 milliseconds, 132 milliseconds. I wait a lot more over here. There's some activity here in the parent. When we receive these messages, 30 milliseconds. Tw 28 milliseconds, that's not so bad. 30 milliseconds combined. 30 versus 34. Then predictor, learn, and predict. Now, predict, learn takes 2. What is this predict? Predict shows up in here. Cache. Network predictor. 48 milliseconds spent doing that. Message task run. 36 versus 48. stream input event, 10 milliseconds. In the bad case, we have this refresh driver notifier in the parent, a vsync thing, runs 6 milliseconds here, it runs 14 there. Input stream ready, 10 milliseconds here, 12 milliseconds there. Document. Ooh, what is this? Run notify possible document change. Set title. That I don't see over here. So notify possible title change. Notify possible title change happens here in the content process, and in the parent process here. That's about comparable. Still don't see it. I do not see where the time is going. This takes 58 milliseconds. This takes 60 milliseconds. There's a big ass gap. Pardon my language. There's a big gap here. We're back in the content process now. I think we just like wait around, spin lock. We wait for 44 milliseconds in that one, and then we're waiting for less time here. Waiting, not waiting as much. 2 milliseconds, 12 milliseconds. Waiting, waiting, waiting. Waiting for synchronous messages to come back. So that's the delay. So at least we know that much. I think the problem, so if the content process is trying to like process stuff and fire an event that the Talos test is waiting for, and in doing so, it sends a bunch of these synchronous messages, and I suspect that the parent is busy. In the bad case, it's too busy to respond to some of these because it's doing something. I don't know what it's doing yet. But I think that's what's going on. We're too busy. Like, let's try and zoom in a bit more. Zoom in a bit more. 36 milliseconds. We're waiting about the same amount here. Waiting and waiting. And the parent. Oh, sorry. I shouldn't be looking in the parent. 40 milliseconds here. 34 milliseconds there. 6 milliseconds here. 12 milliseconds there. Just wait a bit more. And what's the parent doing? The parent is itself waiting sometimes. In fact, it waits for 36 milliseconds here, and it waits for 38 milliseconds up there. We are sending an object. We run some script. Just looking at the parent process, 98 milliseconds versus 130. And what's the difference? Let's get rid of some noise. Let's get rid of content 2 in the compositor. Let's just look at the parent process. drawing, render with core, paint, 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 painting a little more over here. And it does a lot of weighting there. I'm going to zoom in even further, get rid of this weighting, like zoom out of the weighting. I'm going to zoom in here, I'm going to zoom in here. So we have these 4 frames, 1, 2, 3, 4. Good, bad, good, 68 milliseconds, bad, 102 milliseconds. Malloc. We're mallocing because we're drawing. What are we drawing? We're painting. And we malloc. In the good case, we are sending some kind of object here. I don't get that. Swap pointers. That's the profiler overhead. Hash table lookup. Because why? Because an observer. Oh, right. Profiler again. Here's the cache, the Neko cache. Let's look at just Neko. A little bit more Neko stuff going on. Wonder why. Hello? Prediction. And that's prediction learn. And over here it's prediction prediction. And invoke some callbacks. Message prediction. Let's zoom out a little bit. In general, how much time do we spend doing Neko things throughout this whole profile? 92 milliseconds in the bad case. 66 milliseconds in the good case. We do more Neko stuff and prediction, predict. Do all this prediction, 28 milliseconds. Predict, 18 milliseconds. That's not a huge difference. I don't know, folks. I'm going to keep examining this, but I think I'm going to have to cap the episode here. That was very frustrating because we got so close, but I don't have any answers. Not yet, but the answers are in there. We got to keep digging, got to keep sifting, and I'm going to find the answer. Thank you so much for watching episode 103 of The Joy of Coding. I hope that was enjoyable for you. Let's see here. Do I have anything to say before I call it? I'd love it if you rated this episode. There's a link in the agenda to rate the episode and let me know what you thought. I read all of the ratings. I'm going to drop that in the Twitch chat. I already did, but I'm going to drop it again. And let me know what you thought. You know, was this interesting? Did you want to see other things? Let me know. I read all of the ratings that come in. I would really appreciate it. I want to know. So thank you so much for watching episode 103 of The Joy of Coding. Next week, there is no episode. Let me actually update the agenda. No episode next week. I am traveling. So I will not be able to do episode 104 until the week after. So no episode next week. So sorry about that. So I will see you the week after that. Thank you so much for watching. Take care. All the best to you. Bye-bye. Hang on. Gotta play the song. Gotta play the song.
The joy of coding.
See ya.